We live in a universe of unimaginable scale and almost incomprehensible beauty. How is the light from stars, galaxies and nebulae fashioned into the spectacular images that have so inspired us over the years? Sitting at its vantage point 600 kilometers above the Earth, Hubble is a window on the universe. The journey to make a Hubble image begins when light from a distant object starts on its way towards us. After traveling across the vast distances of space, it is captured by Hubble with its 2.4-meter wide mirror. The light is then sent to one of Hubble's several cameras, where the photons are turned into an electrical charge by a CCD chip, rather similar to the ones in digital cameras. The advanced camera for surveys, for example, contains over 16 million picture elements or pixels. One of the challenges in making images is that there is a huge range of brightness in nature from faint to bright objects, and astronomical images are so rich in information that our eyes and computer screens cannot show their full content. Nature can be difficult to capture in a single photograph, and most of us have encountered situations like the following. Imagine you try to take a picture of a landscape. When you do so, you can either capture the bright parts of the sky or the darker parts of the vegetation, but rarely both together. The job of the image processing specialist is to compress this range of brightnesses together so that we can see all the nuances. Image experts use the program FITS Liberator, pioneered by ESA, ESO and NASA, to produce a magnificent rich image which can be interpreted by our eyes.
But is this what we would see with our eyes if we could look through Hubble? Well, not really. Look at this image of the cigar galaxy. This is what Hubble sees in visible light. Our eyes aren't actually sensitive enough to be able to detect the faint light from this distant object, even when looking through a telescope. The reason why Hubble's instruments can do it is because they can gather and add up the light over an extended period of time, which is something our eyes can't do.
Furthermore, some telescopes can see wavelengths that we can't see with our eyes. This multi-wavelength view shows us much more than our eyes, or any one telescope, can see. Parts of this image were made with the Chandra X-ray Observatory in X-rays, and part with the Spitzer Space Telescope in infrared light.
In this episode, we have seen how the images that have emerged